This time I tried using both HyperFrames and Remotion to compare them.
I made the same video with both, and I'm walking through the differences and benefits I found.
We often get asked on this channel what we think of HyperFrames.
Yeah, you see it mentioned a lot alongside Remotion.
It's from HeyGen, the AI avatar video company. It hasn't even been out 6 months, but it's gotten a lot of buzz. Both are tools built around the same idea for the AI era, editing video through programming.
Remotion is the framework where you write videos in React, right?
HyperFrames is the framework where you write videos in HTML and CSS. By the way, we've been using Remotion for over 6 months now on our videos.
We covered our video production workflow for this channel in an earlier episode. If you haven't seen it, check that out too.
So this time, I wanted to see how HyperFrames actually compares to Remotion. I rebuilt one of our usual videos in HyperFrames to test it out, and based on what I found, I'll give you the honest rundown. How the writing experience differs, and what each one's strengths are. Which one you should pick if you're starting fresh, and whether Remotion users should consider switching.
Making videos with HTML, I'm still not quite picturing it.
Yeah, let's walk through how HyperFrames actually works together. What you write in HyperFrames is just regular HTML, like any web page. You place divs and lay them out with CSS, that's it.
So there's no special syntax just for video.
Right? If you're used to building websites, you can write it the same way.
But that just sounds like a regular page. Where does the video part come in?
You specify when things appear using HTML attributes. Like, this element shows from 0 to 2.5 seconds. You set the start and duration.
So the timing is baked right into the tag.
Exactly. Do that for every element and you end up with the video's timeline.
So how does that actually turn into a video?
It opens the HTML in a browser and captures it frame by frame. It shoots the state at 0 seconds, then the next frame's state, and keeps repeating that. Once it's done capturing, FFmpeg stitches everything together into a video.
So under the hood, it's really just sequential screenshots. But writing it all in HTML sounds like a lot of work.
That's the point. HyperFrames isn't really meant for humans to write. It's a library built for AI agents to make videos. The design is basically, it's fine if it's hard for humans to write, as long as it's easy for AI. The Remotion we use on our channel is built around React. That's its defining feature. It hands you a frame number and an empty canvas, and says, draw whatever you want with React. A video is basically a function of an image over time. If you change the content every frame, you get animation.
So it's not like HyperFrames, where you write when things appear as attributes.
A component receives what frame it's currently on, and decides what to render based on that value itself.
So you can write something like fade in over 0.5 seconds as a calculation.
When you want to shift the timing, you wrap it in something called a sequence. If you want it to start at frame 90, you just wrap it with that setting. The component inside gets recounted from frame 0.
So inside the wrapper, you don't have to worry about when you're actually showing up.
You can nest sequences inside other sequences too. So you can build finer timing within a scene. There are basically 3 big advantages to writing it in React. First, you can use web technologies directly. CSS, Canvas, SVG, WebGL. All of it carries straight over into video. Second, you get to use actual programming. Variables, functions, external API, formulas, algorithms. You can drive motion with all of that. Third is the strength of React itself. You can break things into reusable components, and NPM packages just work.
It's nice that you can manage video the same way as web dev components, breaking it into small pieces.
The tooling for development is solid too. TypeScript gives you types, and you can write tests. You can even use Storybook to view a single component in isolation and check it. If you're familiar with modern front-end development, you're already set. Your everyday web dev knowledge carries straight over with this library.
I get the rough idea of both libraries now, so I'd like to hear a bit more about HyperFrames.
Let's dig a little deeper into what makes HyperFrames different, then.
You said earlier that the display window is set with attributes, but how do you add motion?
For that, there's an animation library called GSAP. That's the standard approach. What's interesting is you build the timeline while it's paused, and just register it.
Paused? Then nothing would move, right?
Every time the renderer captures a frame, it moves that timeline to the matching point in time.
That's kind of like dragging the seek bar in video editing software.
Pretty close. So no matter which second you capture, you always get the exact same image. Because of this design, it can sync accurately even with external animation libraries. There are 7 supported runtimes. Besides GSAP, there's Anime, JS, CSS keyframes, Lottie 3, JS Web Animations API Type, GP.
I've heard of Lottie, but what exactly is it?
It's a format that lets you play animations designers made in After Effects directly on the web.
And that can be brought into HyperFrames too.
Yeah, the design is basically anything you can seek into can be plugged in. It's just HTML and CSS you're writing here, so you can bring in the styling from an existing web page directly.
That sounds handy for something like matching your company site's look.
Also, there's a huge number of commands, over 30 of them. It can detect beats in music and transcribe speech word by word. It can also do local text-to-speech and even remove backgrounds.
Beat detection, is that for timing scene changes to the music?
Right? It figures out where the beats land in the track ahead of time, and you sync your cuts to that.
Word-by-word transcription, is that like highlighting captions one word at a time?
Yeah, that's the style you see a lot in shorts. It can generate that out of the box. There's a good range of output formats too. Besides MP4, it can output WebM, GIF, or an image sequence.
What would you even use an image sequence for?
It's for loading into editing software, like After Effects or Nuke. You can pass it through with transparency intact too. So let me show you how to actually get started with HyperFrames. All you need is Node, JS22 or later and FFmpeg, and running the init command generates a starter template. It comes with a few sample projects too, so you can start from scratch or tweak an existing one. As for how you write it, it starts with placing an outer box. That box is what defines the video itself. You write the width, height, and total duration there, like 1920 by 1080 for 30 seconds.
And inside that, you put whatever you want to show.
For the elements inside, you specify when they appear and how long as attributes, say from the 3-second mark for 5 seconds, and it only shows during that window. You specify time in seconds, so you don't have to count frames.
So you don't have to calculate stuff like starting from frame 30.
One catch here. It's not just about the attributes. You also need to add the clip class, or the element will just stay on screen forever. That's the one thing to watch out for. You can also specify which layer it's on with a number.
Kind of like layers in video editing software?
Exactly. And the higher the number, the more it comes to the front. When you place audio or video, there are a few dedicated attributes for that. You specify where in the source to start playback, the volume, and the playback speed. Each of these is its own attribute.
That sounds handy when you want to use a clip starting partway through.
You can also load a separate HTML file and embed it as a component.
So you can split files by scene.
You can pass values in when you load it. That lets you reuse the same component multiple times with different content. The values you can pass are declared ahead of time. You can specify types too, like strings, numbers, or colors. Also, if you add an option in it, you can use Tailwind too.
So the class names you always use just work as is?
Once you've written it, you spin up the dev server and check it in the browser, edit and save, and it updates right there.
Feels just like regular web development.
Finally, run the render command, and you get an MP4. Using the publish command, you can even generate a shareable URL. Let's talk about the differences between Remotion and HyperFrames. I'll walk through what I found out. The biggest one is that they're opposite in terms of who owns time. In Remotion, each component drives this itself. It pulls the current frame number on its own. In HyperFrames, there's a timeline on the outside, and the renderer comes to sync itself to that time.
So if it's flipped, what actually changes?
It affects how you build components. A Remotion component knows when it appears just by being placed, so it's self-contained. In HyperFrames, the HTML for how it looks and the timing spec live in separate places.
If the number of scenes grows, isn't it a pain to track down those specs?
That's actually what happened. All the timing for every scene ended up piled into one outer spot. I tried writing one scene from our usual videos in both frameworks. The stat cards look, and the part where the numbers animate. In Remotion, that all fit inside a single component. In HyperFrames, the look is in the HTML, and the motion is split off into the outer timeline.
So even though it's the same thing you're building, it ends up split across different places.
There were spots where the ease of writing flipped too. Take lip sync, where you snap between states every few frames. In Remotion, you can just divide the current frame number and write it in one line.
Is it different in HyperFrames?
That system is built for smooth, continuous motion over time, so it's not great at snapping between states. In the end, I had to calculate and rewrite it manually every frame. On the flip side, dropping in existing animations like GSAP or Lottie was way easier in HyperFrames. The flexibility for nesting is different too. In Remotion, you can nest sequences inside sequences as many times as you want. In HyperFrames, where you can place audio or video is fixed. It only plays if it's directly under the outermost level.
So what do you do if you want to build a component with its own sound effect?
You basically have to pull the sound out to the outer level, put it inside the component, and it just won't play. I also compared the AI-facing tooling, and both frameworks actually have something for that. Remotion has a knowledge base covering how to write things. HyperFrames has a workflow covering the actual work process. Hand it a site URL, and you get an intro video. Hand it a GitHub PR, and you get a code walkthrough video. It's split up by entry point like that.
So what you feed in is different. One's knowledge, the other's a process.
Right? Remotion teaches you how to write things and leaves the rest up to the AI. HyperFrames asks what you want to build and carries you through the process from there. I also compared the editing screens. Both come with a UI that feels like video editing software. But what you can actually do there is different. In Remotion, if you define props with a schema, you can change the values through the GUI, and it writes those changes back into the code.
What about when you just want to nudge something's position?
That means going back into the code. You can't just grab an element on the canvas and move it. HyperFrames can do that.
So you mean you can edit it directly, like in Figma?
Pretty close. Drag a clip on the timeline, and it directly rewrites the start time attribute. It doesn't keep a separate project file format. So when you open it later, you can see exactly which attributes changed. There's also a button right in the editing panel to ask the AI to make changes directly.
So you can go back and forth between adjusting it yourself and asking the AI.
So let me talk about how the actual port went. First off, I was able to build something equivalent to our usual video. A lot of our setup isn't tied to Remotion specifically, so quite a bit of it carried over as is. That said, there were some traps. Take a repeating motion, like a character floating up and down. Writing it as a CSS animation is the most natural approach. Writing in HTML and CSS is the whole selling point. So naturally, that's how you'd write it. But doing that made rendering more than 18 times slower.
So what's the right way to write it, then?
Rewriting it with GSAP, the animation library HyperFrames standardizes on, fixed it. The inspection tool has both strong points and gaps. It's great at catching things like a missing class or a line that would end up silent before you even render. It even checks quality level stuff, like color contrast being too weak. On the other hand, there's a gap where broken CSS gets no warning at all. It just lets the render finish without complaint.
Does that not happen with Remotion?
That's less to Remotion's credit, and more thanks to TypeScript. Since even styles are written entirely in code, a mistake stops the compile. You can add TypeScript to HyperFrames too, but then you need a build step, and the CSS part still doesn't get checked in the end. This inspection tool looked like it could work on Remotion as is, so I tried running it against our current components. It turned up a color scheme issue in an already published video. I'm planning to bring this into our production pipeline right away. What was clearly rough was the editing screen, Studio. When I loaded our 10-minute video into it, it got so heavy it was unusable.
Is it fine with smaller videos?
It runs smoothly for something like a starter template. I don't think it's built with a scale like ours in mind. There's also something that comes up once you build things out further. When I put our whole video into a single HTML file, the check tool threw a ton of warnings telling me to split it into multiple files.
Isn't it fine to just split it then?
Well, the way you split things is HyperFrames' own particular convention. Splitting in Remotion just follows React's own conventions, so there's nothing extra to learn. It's supposed to be built for agents, where humans shouldn't need to read the code much at all. But once you really dig into it, you still run into limits. You end up having to think about adjusting the program's structure like this. And I found myself wondering whether that's really the point. The biggest difference, I think, comes down to how specifically you can describe what you want fixed. If you can say something like tighten this margin by 8 pixels in code terms, Remotion is faster. But for a vaguer fix, like make this bigger, something like that, I think a different tool fits better. That's HyperFrames, where you can touch the screen directly.
So, is this channel actually switching over to HyperFrames?
If we keep our current way of building things, migrating would be tough.
But the port itself worked right.
Being able to do it, and whether we should migrate are different things. It would mean losing what this channel is actually strong at. The person behind this channel comes from a modern front-end background and is comfortable working in React. So the videos are built by combining a set of components that were prepared and maintained ahead of time. The components are managed in a catalog called Storybook. Quality is kept up with type checking and tests. It's a system built on top of the React ecosystem. Moving to HyperFrames would mean leaving all of that behind. There are also components that carry their own sound effects internally. HyperFrames has that constraint where you can't place audio inside a nested component, so that unit breaks apart. Also, that hands-on editing screen I mentioned earlier wouldn't really get used in our workflow.
Wouldn't it be easier to just adjust things by touch though?
We've always adjusted things pixel by pixel, hand editing the code the whole way. That way it leaves a diff, and it's reproducible. So HyperFrames' biggest selling point just doesn't translate into value for us. For this kind of setup, building things out on top of a foundation you've already put in place. Remotion is the better fit, I think. On the flip side, for a workflow where you have I generate everything from a single one-shot prompt, I think HyperFrames is a better match for that. So I tried out both HyperFrames and Remotion, and compared them in a bunch of ways. To sum up, I think HyperFrames is the better choice for people who aren't familiar with programming. It's also better for those who struggle with environment setup. You can start with just a single HTML file, so you almost never run into installation trouble. It also seems like a good fit if you're just cutting and stitching together AI-generated video clips. If all you're doing is lining up clips and overlaying captions on top, that's a simple case. Writing it in HTML is the easiest way to go.
So if you're not sure, HyperFrames is the way to go.
If I had to recommend just one, right now I'd say Remotion. I think it wins on both extensibility and maintainability.
But isn't learning React the harder part?
Yeah, HTML is definitely the easier entry point. But once you learn the React way of doing things, it carries over directly to other kinds of development. Whereas HyperFrames' own conventions are different. No matter how hard you work to learn them, they don't transfer anywhere else. So in terms of getting a return on that learning cost, I think it actually flips the other way. That said, keep in mind HyperFrames has only been out for 4.5 months. Reaching this level of polish and moving at this pace in that time is genuinely impressive. Even the issues we ran into this time might get fixed soon. I'm honestly pretty excited to see where it goes.
Okay, if things change, I'd love to hear about it.
Yeah, if something major shifts, I'll test it again and report back. If there's anything else you're curious about, let us know in the comments. The same goes if there's something you want us to try.
Alright, see you next time.